Hi, welcome to part 3 of the Capsulan video series about impulse and momentum. In the previous video, we have manipulated the formula of impulse to understand where the formula and definition of a momentum of an object is coming from. In this video, we are going to revisit the second law of motion and learn its relation with the impulse or momentum. Let's start this lesson by recalling the relation of impulse and momentum from the previous video. Net force multiplied by the time of impact is equal to mass times final velocity minus mass times initial velocity. The quantity which is equal to the product of the mass and the velocity of an object is called momentum. So this expression is equal to final minus initial momentums. In physics, the difference of final and initial values of any quantity can be represented by symbol delta. Therefore, we can bring the two ends of this long line together and write as a single equation. Product of the net force and the impact time is equal to the change in the momentum of an object. After some altering with this formula, we find out that the net force is equal to the ratio of change in the momentum and the change in the time, delta P over delta T. By doing so, we are able to get another definition for the second law of motion. The resultant or net force acting on the object is equal, or we can say is directly proportional to the rate of change of momentum of an object. At least at the time of recording this video, it is not necessary to add in the exam the last part of the definition, which is in the direction of the force. But especially in trial papers, we may never know for which part of the definition we can get a mark. Hence, it will be better if we add this part as well. According to this formula, if time of contact increases, the net force experienced by an object decreases. This expression is the key phrase in questions related to the applications of the second law of motion in daily life. That's why we have to try to understand it properly. Now, let's solve a couple of examples to understand how to use this formula. In the first example, a rubber ball of mass 0.8 kgs is dropped and strikes the floor with an initial velocity of 6 meters per second. It bounces back with a final velocity of 4 meters per second. We have to calculate the impulse applied on the ball by the floor. As always, we start solving a question by writing a formula. As in most cases, doing so is getting us 1 mark. Net force multiplied by time is equal to the change in the momentum, which is also equal to mass times final velocity minus initial velocity. We must make sure that we start with the first part of this equation. It is this part which will get us a mark. If we write just the second part of the equation, no mark will be allocated, as it is formula to calculate the change of momentum only. Maybe it doesn't make sense, as impulse is already equal to the change of the momentum, but this is the way memos for our exams are working. Just before striking the floor, the ball was moving downwards, and after bouncing, it is moving upwards. Impulse and momentum is one of the topics where, unless it is already specified in the question, we are required to specify which direction is positive and which direction is negative. For this question, let's choose upwards as a positive direction. In this case, the final velocity will have value of positive 4 and initial velocity is going to be minus 6. Mass of the ball is 0.8 kgs. Impulse of the object is 8 kilograms meters per second. Positive result means the direction of the impulse applied on the ball is upwards. In the second example, a bullet of mass 10 grams traveling east at 500 meters per second strikes the block and passes straight through it with a constant acceleration. It emerges from the block at a velocity of 200 meters per second. We can ignore any loss of mass of the bullet. If the bullet takes 0.002 seconds to travel through the block, calculate the net force experienced by the bullet during this time interval. In this type of questions, where we have a lot of text and which can confuse us a lot, it is a good idea first to draw a diagram or a picture of what is going on. There are two sides of story in this question. Before bullet strikes the block and after it emerges from the block. Hence, let's split the diagram into two parts, before and after. Initially, mass of the bullet is 10 grams and its velocity is 500 meters per second. Afterwards, the mass of the bullet is still 10 grams, but its velocity now is 200 meters per second. As bullet is moving only east, let's choose it as a positive direction. We are asked to calculate the net force. Therefore, we start the solution with the newly learned equation of the second law of motion. Net force is equal to the ratio of the change in the momentum and time of impact. Delta P can be written as mass times V final minus V initial. As unit of mass, we use kilograms. So 10 grams will be written as 0.01 kgs. We can recall that 1 gram is 1000 times smaller than a kilogram. Final velocity is 200 and initial velocity is 500 meters per second. The bullet passes the block in 0.002 seconds. Net force applied on the bullet by the block is minus 3000 newtons. Getting a negative answer means that the magnitude of the force is 3000 newtons, but its direction is west. In this video, we have revisited the second law of motion and learned about its relationship with the impulse or momentum. Then we have solved two questions related to the formula of the second law of motion. In the next video, we are going to see some real-life applications of this formula. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.